Part 2, I will continue by looking at a particular scientific laboratory that I examine. The bug house is the place where I went to examine the daily scientific activity of scientists. I would refer to this place as the bug house because scientists there study bugs, more precisely subterranean termites. I visited this lab for the duration of a project called the Foraging Project, which lasted about 3.5 years. Basically, I shadow a group of scientists. Wherever they allow me to go, I went. Let me just say, the most important aspect of the work of these scientists was a shift from traditional taxonomical practices, what we call keen, to emerging taxonomical practices, using chemical means to detect differences among species of termites. The former, this group thought of it as quite subjective. The latter one, they thought of as a quite objective approach to taxonomy. Let me give you a photo tour of the bug house to show you the kind of work these people did there. The top row shows images of work at field sites. Those were urban and non-urban places where they systematically accessed and collected termites. The next row shows images of lab work. Inside labs, there were collections of live termites brought from field sites. Scientists inside these labs examined termites in different ways. They also kept track of the wood that termites have eaten as a way to study the applied aspects of termites. On the bottom, we do not see termites or woods or complicated instruments any longer. All we see are people with papers or people with other people's and papers. Those images show what typically takes place at a setting called the center, or the place where scientists gather to evaluate their work, discuss it, and produce claims. The production of those claims is done chiefly with representational systems that emerge from field sites and labs. Collectively, all those images represented a flow of work across those three settings. Through this flow, things and people move from field sites to labs and from labs to the center. From the center, there is also a flow back to labs and field sites and to the outside world in terms of claims and publications. We can think of this network as the organization of work inside of a scientific laboratory. This organization may differ in some respect across disciplinary, but its general structure is found across many scientific disciplines. Two important points I want to emphasize from this conceptualization. There were different contexts or settings in which people did different things, but those things needed to be closely coordinated across those settings so that claims can be considered scientific. I will say more on this later. That coordination is represented by the flow. Importantly, people must also get a good sense of this coordination if they want to learn to do this kind of work or develop as practitioners of science. At the bug house, I followed that flow of work for about 2.5 years. I employed some conceptual categories in order to understand how scientific claims were being produced there. Those categories consist of questions such as what emerged for scientists as the leading problem at each of those settings, what resources they use and how they use those resources to address that emerging problem, and how they organize themselves to do that work. Answering these questions led me to some theoretical categories from which I constructed the conceptual framework I offer in this presentation. Here I present those categories as statements inside the cells of this matrix. which collectively form the conceptual framework I offer. Let me then summarize my appreciation of how scientific work can be conceptualized. Later, I will examine how such conceptualization can be used for educational purposes. Let's start with field work. Getting systematic and sustained access to the organism is what concerns scientists the most at fieldworks. Think of it this way. Without systematic and sustained access to an organism or to a natural phenomenon, there's basically little chance of constructing a scientific claim. In order to assure the systematic access, scientists at the House use mostly material resources as well as representational forms to transform a forest or an urban home into a mathematical grid that supported systematic access to the phenomenon. They also relied on existing structures like trees, houses, and the social behavior of termites to place monitoring stations within that grid. Scientists organize themselves collectively to do this kind of work, often grouping individuals with different levels of expertise. Field work was an entry point for newcomers to the discipline of entomology at the House, and also for getting help by others who did not do field work routinely. At labs, the leading problem that emerged for these scientists was how best to examine the organism so that such examination can support the type of claims these scientists were trying to construct. A popular image of science in the schools is someone doing something with test tubes inside of a laboratory. We rarely see an image of someone writing something after such doing. I propose that the leading activity in labs is to transform matter into science. Think of it this way. Termites and wood come into labs, and what comes out are tables, charts, plots, and values organized in very particular ways. To do those transformations, people use an array of instruments. We all have images of those instruments inside labs, and particular representational templates like tables, charts, etc., etc. Interestingly, lab work is often performed individually. At the House and in many other labs, I think, people are often assigned to one particular lab procedure, and they are held responsible for that. Finally, at the center, what challenges scientists the most is how best to represent the organism or the natural phenomenon. And representing here is used in a broad sense, including selecting the best way to speak of and describe natural phenomenon, the best way to show data that support your claims. The resources to do that are mainly representational forms, talk, and experience. That is, graphs, charts, tables, and disciplinary talk, what Lemke calls science talk. At the center, you must learn how to organize representational forms. You must also learn how to talk science, to use Lemke's terms. All this work is always done collectively. The bidirectional black arrows on the leftmost column represent the coordination that needs to exist across all three settings and activities in order for claims to be considered scientific and for people to learn how to do this scientific work. I refer to this process as intercontextuality, or the ability to link tasks across all three settings and be aware of the implication of such links. I propose that this conceptual framework could help us guide the design of more authentic learning environments in schools. In the next part, I will address that issue.